So today we are going to start our new unit, which is going to be about graphing quadratics and exponentials. So specifically today we are going to start looking at graphing quadratics. Okay, and we are going to look at graphing quadratics in vertex form. So we need to go a little bit backwards here before we can go forward. The key is that, remember when we first started graphing, we could graph functions, and they were linear functions, either by knowing a format that it was in, like if it was in slope-intercept form, if it was in point-slope form, if it was in standard form, or we could graph by making a table, okay, and plugging in input values and getting their corresponding output values. So we're going to look at those same types of ways of graphing over the next few days. And the first type that we're looking at today in vertex form means that we are starting with a formula. So the types of graphs that we are looking at today will be in the formula y equals a times x minus h squared plus k. Now, there's a few things that we need to know before we can start talking about how and what we do with graphing this, okay? When we graph a quadratic, it always makes a parabola. Okay, so y equals x squared is going to be this first piece of a parabola that I'm looking at. I'll make my table a little lower here. Okay, and if I have values of -2, -1, 0, 1, and 2. Okay, plugging in those values says take -2 and square it, right? So -2 squared is 4. -1 squared is 1, 0 squared is 0, and so forth, right? And so if I was graphing this on the coordinate plane, I would be plotting points at -2, +4, -1, 1, 0, 0, +1, 1, +2, 4. Okay, and you'll see this sort of U-shaped graph. So every quadratic we're looking at makes this U-shaped graph that we call a parabola. Okay, so when we're graphing these, the shape is always going to be a parabola. Okay, and that parabola can either open up and look like a U, or it can open down and sort of look like a hill. Okay, so the letter A is going to determine if this parabola opens up or down. Okay, if A is positive, okay, so greater than 0, if A is greater than 0, which means it's a positive number, then the parabola is going to open up. Okay, if A is negative, which means it's less than 0, then the parabola is going to open down. Okay, and this is very similar to the idea of slope, right? If we have positive slope, the line goes uphill. If we have negative slope, the line goes downhill. Okay. A parabola also has something that we call an axis of symmetry. Okay, and the axis of symmetry is the line that cuts the parabola in half, which means like if I could, it's kind of hard to show on camera, but if I took my paper and I folded this in half, right, this right side would match up exactly with this left side. Like I said, that's called the axis of symmetry or the line of symmetry. We'll see either. Okay, and the axis of symmetry is found by writing down x equals, it's an equation, it's a line, and vertical lines are always x equals h. A parabola also has something that we call a vertex. The vertex is the very middle of the parabola. It's the very tip top of a peak if it opens downwards, and the very low point if it opens upwards. So this right here is our vertex. Okay, and we find the vertex by using H and K. Okay, so H comma K is what makes up our vertex. It's an ordered pair, it's a point. Okay, so our vertex is always that high point or the low point. That max, we call it the maximum or the minimum. Okay, and we find it by doing H, comma, K. Okay, so if we can do all those things and find those pieces, this is going to give us enough information to be able to graph a parabola. Now, I always tell my students, just take a deep breath here at the moment because it's new, it's a different type of graphing. But after we do it a few times, they're fine. So let's say that we want to graph y equals, and then we have x minus 2 squared plus 3. Okay, so we sort of identified the 3 pieces that were useful, the a, the h, and the k. So if we look at this equation, let's see if we can find the pieces. Okay, so we have a, we have h, we have k. So a is the number in front of the parentheses. So in this situation, a is going to equal 1, right? We don't see a number there at all, so it's 1. And in fact, everything we're looking at today is either going to have an a of positive 1 or an a of negative 1. Okay, H, now we have to be careful with this one. You have to remember our rules from last trimester, right? In a formula, when we have a negative sign, that also means the opposite of. So even though this looks like a negative 2, that subtraction is part of the formula, so our H value is really positive 2. Okay, and then here on the end is our K value. The K value of the formula already had an addition sign, so K is 3. Okay, so we know that since A is positive 1, this is going to be a parabola that opens up. We know the very center of the parabola is going to be at x equals 2. And the point of the center of it is the vertex, which is 2, 3. Okay, so to graph this parabola, we then want to plot this ordered pair. So I'm going to plot the point 2, 3. Now, because we are only looking at quadratics that have a is 1 or a is 1 or a is negative 1, we're going back to this idea of a value being squared. Okay, so negative 2 squared is positive 4. So what it's telling me is that from this point, if I move left 2 squared is 4. And because this parabola opens up, I'm going to go up 1, 2, 3, 4. Okay, if I go back to the vertex and I move over 1, 1 squared is 1, and because it opens up, I'm going up 1. Okay, so I could, from this vertex point, go left 3, and 3 squared is 9, so then I would go up 9. It just doesn't fit on my graph. Okay, and I'll do the same thing on the right. If I go right 1, 1 squared is 1, so I'm going up 1. And if I go right 2, 2 squared is 4, so I'm going up 2. And this gives me my parabola. Now, I will have you list something else for me, and that's I will have you list a point and a symmetric point. Okay, when I'm asking for a point and a symmetric point, I'm simply asking for either this pair of points or this pair of points. Okay, I'm asking for the 2 points that sort of have the same pattern, right? Left 1, up 1, right 1, up 1. And we just do that to check and make sure you actually know where the points are and that you aren't just graphing the vertex and throwing on a quick U. Okay, so if I asked you to graph or to name a point and a symmetric point, you could either pick the point 1, 4 and pair that up with 3, 4. And whichever point you listed first or second doesn't matter. Or you could list the point 0, 7 and pair that up with 4, 7. And And again, it wouldn't matter which point you put first. Okay, this is called your point and your symmetric point. So let's take a look at another one. Okay, and so we're going to see how we're doing. So let's say we wanted to graph y equals negative x plus 5 squared minus 2. Okay, so we're going to find a, h, and k. So a equals negative 1. It's the number in front of the parentheses. H is always the opposite of what it looks like, so it's going to equal negative 5. And k is negative 2. Okay, so because a is negative 1, we know that this is a parabola that's going to open down. And we know that the axis of symmetry, or the line of symmetry, that line right in the middle, is going to be x equals negative 5, right? It's x equals h. Then we can name our vertex in this specific situation. Okay, h comma k is negative 5, negative 2. So now we'll plot that ordered pair. So now we're going to plot the point, negative 5, negative 2. And following our rules of numbers squared, right? Because this is a quadratic with it being squared. If I go over 1, 1 squared is 1, but this opens down. So I need to go over 1, down 1. Okay, from my vertex, I go over 2. I'm going to go down 1, 2, 3, 4. 1, 2, 3, 4. See if I can count that right. Okay, and then I'll do the other side. Over 1, down 1. Over 2, down 4. Again, if I were to go over 3, I would go down 9. If I were to go over 4, I would go down 16. Okay, so last one we're going to look at just to make sure we're really set on this. So if we have y equals x plus 2 squared plus 3. I just changed some signs up from the first one a little bit to make sure we're good. Okay, we'll say a is 1, h is negative 2, k is 3. This parabola will open up. It will have an axis of symmetry at x equals negative 2. And our vertex is negative 2, negative 3. So I will plot the point negative 2, negative 3. And this is opening up, so I'm going to go over 1, up 1, over 2, up 4. And then I'll do my other side. And there is my graph. Now again, if I needed a point and a symmetric point, I could pick either these 2 points and name them, or these 2 points and name them.